Hello everyone, I Sai Sankirtana and my teammate Desmond for our coursework of HAP 786, which is Workshop in Health Informatics, which is taught by Professor Dr. Farouk Elemi. We are going to present a presentation on the topic Analyze Missing Values. For this, we used all of us researcher program for our further analysis. To begin with, the language output will link to the input to machine learning. So the All of Us research program is mainly focusing on gathering health data from different diverse backgrounds, which is going to help create and more personalized medicine. So the goal is to better understand on how genetics, environment, and lifestyle will affect the health and also tailor healthcare treatments to the individual needs. Our project mainly focuses on developing an interface between AI chatbot and also machine learning system to be able to identify the patients who are taking antidepressant and also the likelihood of having these depression based on previous prescription and also the medical history. So our project mainly uses All of Us research program, which is a depository containing electronic health records data from various sources for patients who have agreed to participate in the research program. Our study is to develop an AI-based mental health system that can diagnose depression and recommend the most effective medicine based on patient's response. By analyzing this data and also uh, patient medical history data and also the current medications and treatment responses, the system will identify which drug is most likely to be beneficial for the patient. That drug we are going to prescribe to the patients. So the main goal is to optimize personalized treatment plans, which is going to enhance drug efficacy and also ultimately is going to improve the mental health outcomes by identifying most likely drug which is to be effective and also recommending it to the patient, which is based on their responses and medical history. To begin with, first we have to create a cohort for all the participants. So this we do by selecting a default folder which includes all the participants. So a cohort is referred to as a group of individuals who are being observed or also which are individuals being studied over time. So first we have to begin with creating the demographic data set, which includes person ID, gender, date of birth, and sex. Then we're going to add target concepts to it, which is condition, measurement, procedure, and the observation. Before we run antidepressant history, we have to create a new notebook, which is called notebook to run. And then we have to run the notebook in background. And then this will give us a new notebook and then which is also called as the output file. We run a notebook in the background because this will keep an automated system or data processing notebook such as Jupyter to actively work out without the need of constant monitoring or user input or supervisors. So this mainly improves the efficacy, accuracy, and consistency in the data management and analysis workflows. So it also allows us to process larger data sets while avoid triggering. If we perform larger data sets in the normal notebook, it's going to be triggered. So that's the reason we are gonna run this in the background, and also it will protect the mechanisms in all of us research program, which is mainly designed to prevent unauthorized and unintended data downloads. Once we add up our notebook to run, we are gonna constantly, um, for every 12 to 15 hours, we are going to use a background job wake up, which is called automatic process or the system which is going to activate, refresh, or wakes up at regular intervals. This will mainly ensure the data collection and processing will continue without any interruptions. So we are gonna just run the statement wake up so that the background notebook will run in a good manner and also it has lots of efficacy.
Antidepressant history. The processing of antidepressant history data ran for approximately 22 to 26 hours, resulting in a new output notebook. This notebook generated a CSV file that consolidated the data by incorporating independent variables. The output file, created during the background data processing, contained rows and columns from the antidepressant history, which were then merged into a single CSV file encompassing all the antidepressant data, along with the added independent variable. For the data analysis in the All of Us project, we utilized 16-core CPU, 60 GB of RAM, and 250 GB of disk in our virtual machine to handle the processing and storage needs. So on the output file CSV, we had to make sure that we have 21 columns. So this is a sample of the columns that we got, and the number of entries was 739,559 for each column. So the dependent variables included demographics, diagnostics, procedures, antidepressant history. Independent variables included all diseases, all procedures, all medications. Everything was saved to the CSV file. We merged all the data into a single notebook for processing while checking and dropping all the duplicate data in our antidepressant history file. This ensured accuracy of the results of our study. So we had 527 targets and 41,480 medical events. Using the medical events, we created files for likelihood ratios, and for our group, we were assigned to run 350 likelihood ratios. So we used this to calculate for each condition that we were given. So likelihood ratio are statistical measures used to assess the probability of a condition being present given a specific diagnostic criteria. Our work file contained 350 SNOMED codes for diagnosis, each with its own corresponding likelihood ratio. We uploaded this work file into the All of Us research workbench for processing. After running the analysis, we obtained an output of 350 files. So each file is the individual SNOMED code for the likelihood ratio that we were running, which is run against the 41,400 medical events to create a file that shows likelihood ratio associated with the diagnosis. This is a sample of the likelihood ratio results for DX SNOMED 341109 file. So the graph below the slide shows the top 10 medical events associated with the diagnosis SNOMED 341009. By focusing on high likelihood ratio procedures or medical events, we can better tailor mental health interventions and identify useful markers in patient histories and inform future research on antidepressant effectiveness. The challenges we encounter were interruption and disconnection. These occurred intermittently while running data analysis, which was time-consuming and disrupted the workflow of our project. We also experienced account suspension. All of us accounts were suspended because the system thought we were downloading data. So we had to fill out forms to declare that we were not downloading any data, and our accounts were reinstated. But the process was time consuming. There was also the danger of loss of data, especially if insufficient disk space was allocated. Thank you for your time.